Hello students, in our last class we had a discussion on the various methods of preparation of haloalkanes. Let us recapitulate it fast. So these were the methods we have discussed so far. Next, we will discuss another method to prepare alkyl halide. That is one of the named reaction called as Hunsdiecker reaction. And the starting material here is the salt of carboxylic acids. When silver salt of carboxylic acids we heat it with bromine in a dry carbon tetrachloride, the salts undergo decarboxylative bromination, as a result of which alkyl bromide is formed, which contains one carbon less as compared to the parent acid. What have I told? In this reaction, silver salt of carboxylic acid, RCOOAZ, when it be treated with bromine in the medium of carbon tetrachloride, and this reaction mixture be refluxed, it be heated, alkyl bromide is formed as the product, which contains one carbon less as compared to the parent acid. Look at the salt of carboxylic acid. Here the number of carbon atom is R plus 1, but here in the product only R is there. This carbon is not present in the alkyl halide formed here. That carbon, it is released in the form of carbon dioxide. That means it is one of the decarboxylative process. This involves the loss of carbon dioxide along with the addition of bromine. So it is decarboxylative bromination plus the remaining product is AgBr, silver bromide. Okay, so this is your complete reaction. RCOOAZ, silver salt of carboxylic acid, when it be heated with bromine in the medium of carbon tetrachloride, we will get alkyl bromide along with the release of carbon dioxide gas and the formation of silver bromide. For example, we can consider one example here, very simple example. Let us consider CS3COOAZ, silver salt of acetic acid or silver acetate, when it be heated with bromine in the medium of CCl4. You can tell me what would be my product? Look at the main reaction. This is your general reaction. RCOO, in the place of R, CS3 group is there. So in our product we are getting RBr. What is R? CS3. So CS3Br. We will get CS3Br plus the side products are same. The byproducts are same. Carbon dioxide and AgBr. Okay. So it is silver acetate, and from silver acetate we are getting methyl bromide. So this reaction that involves steep descending process where the number of carbon is getting reduced. No, whenever we need to reduce the number of carbon in any reaction, then we can think about this reaction. Okay. Similarly, when C6H5COOAZ, this is silver benzoate. Okay, when it be heated with bromine in the medium of carbon tetrachloride and the reaction mixture when it be refluxed, tell me what would be our product? In the place of R, what is there? C6H5. So RBr means we will get C6H5Br. C6H5Br. So bromobenzene plus the byproducts are same, carbon dioxide and AgBr. Okay, so these are the products. What is the product here? Bromobenzene. And this is silver benzoate. Listen students, the importance of this reaction is that is lying here. Exactly by the help of this reaction we can reduce the number of carbon atom by 1 here. We are getting the product which contains 1 carbon less. Okay, so this is our reaction. Next we will find the mechanistic pathway of this reaction. Our reaction is silver salt of carboxylic acid, that is treated with bromine in the presence of CCl4. As product we are getting alkyl bromide which contains 1 carbon less along with the release of carbon dioxide and silver bromide. Okay, just remember we can use accordingly chlorine here. When chlorine be used we will get corresponding alkyl chloride. Okay, evidences show these reactions occur through free radical mechanism. That means this involves the steps like initiation, propagation and termination. So we will present the various important steps here. The starting material is salt of carboxylic acid. We have taken silver salt here. The silver salt, it contains one polar bond, this non-metal and this metal. The polarity is here. This is positively charged and this is your negative pole. This molecule polarizes the bromine molecule. Bromine itself, it is non-polar, but in the presence of this salt, these poles, this molecule gets polarized. This negative pole of this salt that interacts one positively charged site of this bromine molecule, as a result of which this pair of electron that will be shifted to another bromine atom. Okay, then what you will get? RC double bond O, O, Br. One bond will be formed between this oxygen and bromine. Okay, this is a covalent bond, and this Ag plus and this Br minus, they will give rise to the AgBr. This is your side product. This has been shown in the general equation, AgBr. Okay, and this is your acyl hypobromite. Acyl hypobromite, Te. Okay, in the next step, this acyl hypobromite molecule, which has been formed in the first step, in the next step, this involves homolytic cleavage at this particular site. Oxygen and bromine bond, this is homolytically cleaved in the next step. When this mixture is getting heated, when the heating process is continued, this bond will be cleaved homolytically, such that one electron that will lie over this bromine, another electron that will be over this oxygen. So in this way we will get two free radical. One is acyloxy free radical. This is your acyl group, one oxygen is along with it. So acyloxy free radical plus another free radical, that is bromine. So in this way, in this step, we are getting two free radicals. One is acyloxy free radical and second one is the bromine free radical. Okay, and as this steps involves the formation of the free radicals, these free radicals will initiate the reaction. That's why this step is called initiation step. Initiation step. Okay, after this initiation step, where these kind of free radicals have been formed, now these free radicals, they will propagate the reaction. Okay, so in the next step, this free radical which has been formed here, one is acyloxy and second one is bromine free radical. This acyloxy free radical, again it undergoes homolysis at this carbon site, carbon bond. This bond will be homolytically cleaved. One electron that will lie over this carbon, and this carbon that will use this one electron with the unpaired electron of this oxygen to form a pi bond, and this alkyl group that will contain one electron, such that as a result of this homolysis, this bond has been cleaved homolytically. So you will get one alkyl free radical plus carbon double bond oxygen was there. Next, another double bond will be formed with oxygen, such that this is your carbon dioxide molecule. This is another byproduct. Okay, in the first step, one byproduct has been obtained, and in the third step, we are getting another byproduct. So these are AgBr and CO2. These were the byproducts which have been presented in the general equation. Okay. Next, this alkyl free radical, which has been formed in the third step. This is exactly the propagation step. This step could be considered as propagation, because these kind of steps will propagate the reaction. Okay, we can see here how this reaction will propagate. In the next step, this alkyl free radical which has been obtained here in the third step, this alkyl free radical, now it will combine, it will participate in the reaction with acyl hypobromite molecule. Acyl hypobromite, and here also presence of this free radical that will help to cleave this oxygen bromine bond again. The same step is getting repeated here. Listen, in the second step, this acyl hypobromite that was involving the homolysis at this oxygen bromine bond, here also once again the same kind of cleavage will occur, that will be repeated. This R, presence of this R free radical that will help in the homolysis of this bond, such that one electron that will lie with bromine, another electron be with oxygen. So this R free radical and this bromine radical, they will give rise to RBr. This is our product, and along with RBr we are getting RC double bond O, single bond O, acyloxy radical. Okay, this is your product. Once again, this acyl oxy free radical that will participate in the same manner. You can see this third step here, acyl oxy free radical was there. So this acyl oxy free radical, it will participate in the same way. This third step, now it is going to be repeated. When this acyl oxy free radical that will undergo homolysis at this particular site, you will get one alkyl free radical along with the release of carbon dioxide molecule. That alkyl free radical that will combine with another acyl hypobromite to form RBr again. So these steps are propagation steps. So these are the main steps where we can get RBr. So the overall reaction that is important here. What is the reaction? RCOAg plus Br2, we are getting RBr plus CO2 plus ACBr. Okay. So easily we can prepare alkyl bromides or chlorides in Hunsdiecker reaction from silver salt of carboxylic acid. One point is to be noted here. When silver salt of carboxylic acid, they be treated with iodine in the presence of CCl4, generally ester is formed in the place of alkyl iodide. The main product formed here is ester, and this reaction is called as Simonini reaction. What have I told? When silver salt of carboxylic acid, they be heated with iodine. Okay, when this reaction mixture, that the composition is in 2:1 ratio, and this mixture when be heated in CCl4 medium, then ester is formed, RCOOR, along with the release of carbon dioxide and AZI. So this is quite different from the previous reaction. In the previous reaction, what have I mentioned? Silver salt, when it be treated with bromine, we are getting alkyl bromide. Also, when silver salt that be treated with chlorine, you will get alkyl chloride. But when we are taking iodine with silver salt of carboxylic acid, generally we are getting ester as our product. And this modification of Hunsdiecker reaction, this is quite different. This reaction is called Simonini reaction. Okay.